Hi guys, welcome to this video. Before we wrap up the chapter number 4, there are a uh, couple of concepts that you need to understand, and we will cover those in a few minutes. Some terminologies that you must have heard about are adjacent channels, non-adjacent channels. We've heard about overlapping channels. We've heard about non-overlapping channels. When we draw the channels of 2.4 gigahertz spectrum, we know it's channel number 1, channel number 2, channel number 3, channel number 4, channel number 5, channel number 6, 1, 2, 3, 4, 5, 6, right? The channels next to each other, it's 1 and 2, 2 and 3, 3 and 4, are called adjacent channels. The channels which are not next to each other, 1 and 3, 2 and 4, 3 and 5, they are called non-adjacent channels. Overlapping channels are those whose frequencies overlap. Channel number 1 and 2, the frequencies overlap very well. Channel number 2 and 3, 1 and 3, the frequencies will overlap. All those channels whose frequencies overlap are called overlapping channels. And all those channels whose frequencies also do not overlap are called non-overlapping channels, like a combination of 1, 6, and 11. Also, 2 and 7, 3 and 8, so on and so forth. So these are called non-overlapping channels. Okay. A Wi-Fi deployment in 2.4 gigahertz will always happen on 1, 6, and 11 in FCC because in countries where only 11 channels are allowed. Okay, because we get three channels and a combination of all of them are non-overlapping. So that's what we use to deploy access points on. That was the first concept. The second is we need to understand the difference between a data rate and the throughput of a client. If in a dot 11 A radio, my client is connected on 54 Mbps megabits per second, it doesn't mean it has a throughput of 54 megabits per second. No, 54 Mbps is the data rate. This is called the data rate. A supports 6, 9, 12, 18, 24, 36, 48, and 54. These are all data rates. If my client connects on 54 Mbps, it is connecting on a 54 Mbps data rate, not a throughput. Wireless is a half duplex medium technology. So by simple maths, the throughput is at least half of the data rate, which means it is 27 Mbps. Now, add to that some noise, some contention, CSMA, CSMA, CS. Hang on, let me erase that. Yeah. So CSMACA happening. The throughput sometimes becomes around 20 Mbps or so approximately. This means that if I have one client on the AP, I can only take out 20 Mbps of throughput for that client connecting on dot 11A protocol. Okay, dot 11A standard. If I have four clients on the AP, then the effective throughput per client becomes 20 by 4, which is 5 Mbps per client approximately. That is important because when We talk about 54 Mbps. A lot of people think it's the throughput that the client is getting. No, it is not the throughput. It is the data rate it is not the TCP throughput that comes out. It is only the data rate that the client connects on. And it's both ways. So when it's half duplex, it becomes half of it. Then some contention, noise in the spectrum, and CSMACA happening, which makes it approximately 20 to 21 Mbps that the client is able to get out of an AP. Now, if we have four clients, five clients, 10 clients, that 20 Mbps will be shared among those clients, depending on the capability of the client. That is very, very important. So this wraps up this particular chapter. We will continue in the next chapter. Thank you.